Alright, in this problem we have the Dunbar family, which consists of a mother, a father, and some children. The average age of the family is 20, the father is 48 years old, and the average age of the mother and children is 16. And the question asks how many children are in the family. Alright, well, we're given some information here. So actually what I'm going to do is define a couple of variables. Now, because I'm given the average, um, I want to define the things that go into calculating the average. Okay, so what I'm going to do is I'm going to define a variable s to be the sum of the ages of all the family. Okay, so because in order to calculate the average, I would take the sum of all the ages of everyone in the family and divide it by the number of people in the family. Okay? Now that's another thing we don't know. We don't know the number of people in the family. So I'm going to define another variable, but instead of defining it as the number of people in the family, I'm going to define it as the number of children. Okay? So I'm going to say n is the number of children. Okay? And that's just more for convenience because that's what they ask for. And then when I solve for that variable, then I'll know I'm done. Otherwise, I could define it as the total number of people in the family, but then I'd have to make sure at the end to subtract 2 for the mother and father. Okay? But I know I can always, I know that the number of children plus the mother and father is going to be the total number of people in the family. So we're given the average age of everyone in the family, and in order to get that, I would have to take the sum of all of the ages of everyone in the family and divide it by the number of people in the family, which in this case would be n plus 2. It would be the number of children plus the mother and the father. And we're given that that is 20. Okay? That's what we're given here. The average age of the family is 20. Okay? So if I take s over n plus 2, that should be 20. Now we're also given the age of the father, and we're given the fact that the average age of the mother and children is 16. So I also know that if I were to take the sum of the ages of the mother and children and divide it by essentially n plus 1, which is the number of children plus the mother, I would get 16. But I don't have the sum of the ages of the mother and children. And I've defined this variable to be all of the ages. But since the father, we're given that the father is 48 years old, I can actually take s minus 48, and that will be the sum of all of the ages of the children and the mother, okay, because we've essentially removed the age of the father, okay? So the sum of the ages of the children and the mother divided by the number of children plus the mother, we know we're given is 16. Alright? So now I have two equations and I have two unknowns, and that's always a good thing because usually when you have two equations and two unknowns, you can solve for both of those unknowns. So let's go ahead and do that. It just takes a little bit of algebraic manipulation here. First thing I'm going to do, I don't really like the fraction. I don't want to work with fractions. So in order to get rid of the fraction, I'm going to multiply both sides by n plus 2. Right? So n plus 2 over n plus 2 will just give me 1. So I end up with s is equal to 20 times n plus 2. And I can distribute the 20, and I'll get 20n plus 40. Alright, so that's a little easier to work with. Let's go to this one. I'm going to get the n plus 1 off the bottom. So I'm going to multiply both sides by n plus 1. N plus 1. Alright, then an n plus 1 plus over the n plus 1 cancels. That just is 1. So I get s minus 48 is equal to, and I'm going to just go ahead and distribute here, 16n plus 16, right? And I'm going to go ahead and get s by itself. So I'm going to add 48 to both sides. And then I get, 48 minus 48 is just 0. So you get 16n plus, and this ends up being 64. Alright. So now I have two equations for s. I've got s equals n plus, 20n plus 40 and 16n plus 64. So I can actually eliminate one of the variables on this s term, and I can just equate the two because I know they're both equal to s. I can say 20n plus 40 is equal to 16n plus 64. Alright, now I have only one variable. I only have the n, which is what I'm looking for, which is kind of a good thing. So let's move all the terms involving n to one side. So I'm going to subtract 16n over here and subtract 16n over here. So I'm going to get 4n on this side. I'm going to subtract 40 over here and subtract 40 over here. So 40 minus 40 is 0. Here's 16n minus 16n is 0. So over here I get 24. 64 minus 40. So now if I divide both sides by 4, I actually get n equals 6. And we defined n to be the number of children, so that's our answer. The number of children is 6. Alright? And with these types of problems, it's really easy to go ahead and check your answer too. Now what I would have to do though to check it would be to solve for s, okay, the sum of the ages. So, but that's pretty easy. I can just plug in, I can actually plug in s is equal to 20 times 6 plus 40, right, from here. And so that gives me s is equal to 120 plus 40, which is equal to 160. Okay, so now I've got both s and n, and if I use those in these original equations, then I can check my answer. So let's do that. This first equation says that the average age of all the family members is 20. So if I know that the sum of all the ages is 160, and there's 6 plus 2 people in the family, which is 8, that gives me 20, which is what we wanted. So that's good, that checks out. Let's check the other equation. We know that the sum of all of the children plus the mother's ages, or the average of all the children's ages plus the mother's age, is 16. So if I take 160 minus 48 and divide it by 7, that gives me what? I get, let's see, 2 and let's see, 112 divided by 7, and that better be 16. So let's go ahead and let's do the division here quick. 112, 1742. Yes, so that's 16. And you can see that's what we wanted it to be. So that checks out as well. So we have confirmed that this is our answer. The number of children in the family is 6.